Okay. A good day once again, everyone, distinguished scholars. Welcome to week 5, where we'll be dealing with one of the most misunderstood stages of research. Let me begin by asking you a simple question. What is the point of collecting data if you cannot explain what it means? What is the point of collecting data if you cannot explain what it means? And if you are able to answer this question, then you know what data analysis is. Data analysis is not statistics, it's not software, it's not numbers or charts. Data analysis is making meaning from evidence. Making meaning from evidence. And that's why today we'll be looking at data analysis and interpretation, from raw data to defensible knowledge. Data by itself is useless. Well, let me say this ahead of time before we proceed. I'm not teaching you how to, if you came here today hoping to become a data analyst after this lecture, let me disappoint you ahead of time. I'm not going to teach you how to become a data analyst. I'm not a data analyst myself. There are 3 important questions to ask when doing research. There is the what, there is the why, and there is the how. The what is the most basic level. The how it is done, and why is to know why it is done, how it is done. The why question is the most important question. We'll be looking at the what and the why question here, and we'll not bother ourselves with the how question. The how question is for the data analyst to be able to answer. But if you give your data to data analyst, you should know why, you should know what they ought to do for you and why they ought to do them. Then you allow them to do it, knowing how to do it. So let me put out that caveat ahead of time before we proceed. So data by itself is useless. It is analysis that gives it meaning. A spreadsheet is useless. Interview transcripts are useless. Survey responses are useless. It is until you do one thing, interpret them in relation to your research question. Remember, we started out by talking about research question, and everything you do must be related to your research question. It is now when you are able to interpret your data in relation to your research question that it gives it meaning. So why does data analysis exist? There are 5 core purposes for data analysis. One is to answer your research question. Everything you do must return to this, which is, if your analysis does not answer your research question, it is irrelevant. So your analysis is to answer your research question. 2, to reduce complexity. You may have collected 100 responses or 50 pages of interviews. Analysis simplifies this into patterns, trends, and key insights. And this reduces the complexity into something manageable and comprehensible. 3, to identify patterns. You are looking for what is common, what is different, and what is surprising. So you want to identify patterns of what is common, what is different, and what is surprising. And your data analysis helps you to reveal that from your raw data. Your raw data has this, but it conceals it within the body of information it is carrying. So your data analysis helps to reveal this pattern of what is common, what is different, and what is surprising. 4, it is to provide evidence. In research, claims without evidence are mere opinions. Claims without evidence are mere opinions. Data analysis transforms your opinion into defensible, citable evidence. Transforms your opinion into defensible, citable evidence. Number 5, to support decision making. Whether your research is academic or practical, your findings must inform action. Academic action, policy, or any such action. Analysis is the bridge from data to impact. So one of the core reasons why data analysis exists is to support decision making. So data analysis is not about impressing people. It is about making your research understandable, credible, and useful. If you want your research to be understandable, credible, and useful, you have to include data analysis. We have basically 2 types of data analysis. And we'll be looking at what they are used for, each individual type, what they are used for. We have the quantitative data and qualitative data. Of course, there are only 2 types of data. The data can be qualitative or quantitative. Quantitative data has to do with numbers, scores, ratings, percentages, measurements, frequencies, and so on. And the question this answers is how much and how many. How much, how many? To what extent? That's the question that your quantitative data answers. And it requires statistical literacy, software competence, understanding of distribution, and significance to be able to answer the questions of how much, how many, and to what extent. The qualitative data, on the other hand, is words. And examples include interviews, opinion, experience, focus group observations, documents, open responses, and so on. And it is a language-based data. Use words. And the question your qualitative data answers is why? How? What does this mean to people? How? Why? What does this mean to people? Examples are your interview, transcripts, field notes, policy documents, and written reflections. It requires interpretative skills, sensitivity to context, rigorous coding, discipline, and reflexivity. So what we see from here is that numbers explain patterns while words explain meaning. So your quantitative data will establish patterns and your qualitative data will establish meaning. So let's look at quantitative data analysis, where we build from zero, do cleaning, descriptive analysis, and inferences. Your quantitative analysis has 3 sequential steps: clean, describe, infer. Clean, describe, infer. Data cleaning is done before the major analysis to remove errors, check missing values, ensure consistency. So here it removes duplicates or incomplete entries, check for impossible values. For instance, if you have the age of somebody recorded as 999 in year 2026, you definitely know that that is not true. Nobody is up to 900 years, so that must have been an error. You remove such thing. Verify consistency across variables. Document every cleaning decision, as your examiners may ask this, or peer review for journal articles. Your peer reviewers may ask for this. The rule is that do not analyze dirty data. The output is only as clean as the input. So if you analyze data with a lot of inconsistency, you are going to have a result with so much inconsistency. So data cleaning is very, very important before you do your analysis. Then the next is descriptive statistics. This is describing your data. What do you do here? You count responses and calculate percentages. You calculate mean, median, and mode for continuous variables. You identify range, standard deviation, and variances. Please, can everyone still hear me?
Yes, sir.
Yes, sir.
Great, great. Example is 70 of 100 respondents, that's 70%, reported daily AI tool use. That is descriptive analysis. If you surveyed 100 students and 70 reported that they use AI, 30 reported that they do not. If you see 70% of respondents use AI tools, that is a descriptive analysis. The purpose for descriptive analysis or statistics is to describe what your data looks like before making any claims about relationships. You have to be able to know what your data looks like. You should be able to describe them before you can make any claim. So after you do your data cleaning, the next thing to do is descriptive analysis before you move on to inferential analysis. Move from descriptive statistics to inferential analysis. During the inferential analysis, you go deeper, where you examine relationships, whether they are real or by chance. You test whether observed relationships are real or by chance. Here you talk about p-value, that's the significance value. If it is less than 0.05, then you say it's statistically significant, meaning what you are observing is not random. It is statistically significant. The relationship is statistically significant. It is not a random observation we have seen. But if the p-value is above this, then it is not statistically significant. It could mean that what you are observing is just random. For instance, if study time increases GPA, if study time increases and GPA increases, you test, is this relationship statistically significant? If you have seen in a population that students that report that their study time is above a certain threshold of hours, and you also notice that within that group, perhaps their GPA is also high. You want to know, is there a real relationship between study time and GPA? Then you do your test. If you find out that after doing your statistical analysis and the p-value is less than 0.05, you say that there is a significant relationship between increasing study time and increasing GPA, and so it is not random. And that is how you infer. The common tests used for inferential analysis include t-test, ANOVA, correlation, regression. You do not need to calculate this manually. You must understand what the output means. Statistical significance is not always equal to practical significance. Always report what you see. You may see two figures that are markedly different from one another, and you think, oh, there's a significant difference between them. When you do your statistical analysis, you discover that the p-value is above 0.5, and you begin to wonder, why is the values different and the statistical value is not significantly different? Report what you see as your statistical difference, not what you observe. Now let's look at qualitative analysis. In your qualitative analysis, there's also step by step of how to carry out your qualitative analysis. And there are 4 discipline steps from transcript to defensible team. First, you must read and immerse yourself in the data you have generated from your transcripts, from your interviews, and so on. So read all transcripts or documents at least twice before touching a code. First read, understand the whole concept, then read again, and you begin to notice recurring ideas, tensions, and significant moments. Do not code what you have not fully read and understood. So in qualitative data analysis, coding is one of the most important steps. But before you code, you must read and immerse yourself in the data. Ibrahim Aliyu, I see your hands up. Is there any issue? Okay, great.
No, sir.
Then the next is coding. The next is coding. Assign a brief descriptive label or code. Coding is having a brief descriptive label to certain information. For instance, if you find statements like, I don't get enough guidance from my supervisor in an interview transcript, you may code it as lack of supervision. Lack of supervision. So your coding gives meaningful labels to text, a segment of text. Lack of supervision, inadequate supervision, that could be a code that you can use. Code what the data says, not what you expect to find. Codes are descriptive, not interpretative. So you do not code based on your bias. Code only what you are seeing from the transcripts or the documents in front of you. So not what you thought before you carried out the research, but just what you are seeing in front of you. Then the next thing is to group related codes into teams. You group related codes into teams. So codes that share a conceptual meaning. For example, if you have things like inadequate supervision, no mentorship, poor guidance, you can group them into a team of inadequate academic support. So you can have several codes, you put them, once they have the same conceptual meaning, you put them together as a team. Teams are interpretative. They represent a higher order claim about what the codes together reveal. Then lastly, you interpret the themes. Explain what it means and why it is important. For everything, you want to know, what does this mean? Why is this significant? Connect themes back to your theoretical framework and research question. This is where data becomes knowledgeable. If you cannot connect your themes back to your theoretical framework and your research question for a qualitative analysis, your data will not be meaningful. Now again, I understand most of us here are from experimental science background, and so we do not do a lot of qualitative analysis. So this might look new to us, but you find out that as you go higher in your research and training, a point will come that you might need to do qualitative research analysis, and this knowledge will come in handy then. But for those of us in humanities and arts, this is exactly how we do our analysis, qualitative analysis, and this is very important for us. So let's look at data visualization. Why visualization exists. So make evidence visible, persuasive, and publication ready. Humans understand visual faster than text. We process visuals about 60,000 times faster than text. A well-chosen chart is not a decoration, it is an argument. So choosing the right visual form for the right data is very important, and this is what we mean by visualization. And the purpose is to simplify data, highlight patterns, improve communications, and support arguments. For quantitative visuals, we have bar charts, comparing values across categories, e.g. usage by department and so on. We also have line graph, showing trends over time. We have pie charts or donut chart, showing proportional composition. You use only when parts sum to a meaningful whole. Another type of quantitative visual is scatter plot, showing the relationship between two continuous variables. And we have histogram, showing the distribution of a single continuous variable. For the qualitative visuals, we have thematic map, showing how codes group into teams and subteams. Concept map, showing relationship between theoretical constructs. Frequency tables, showing how often codes appear. Quantifying qualitative patterns. Quote illustration, embedding direct participant quotes to evidence themes. Word cloud, showing most frequent terms, useful for preliminary orientation only. So a good chart explains data instantly. A good chart explains data instantly. A bad chart confuses the reader. So if you have a chart on a document, whether it's your thesis or a manuscript, and it confuses the reader, by looking at it, that's a very, very bad visual. A good visual must explain your data instantly, and it should explain it independent of every other part of your work. Just by looking at that data, one should be able to comprehend the message it is passing. You don't need to go and read another section of the work to understand what message that visual is passing. So that is very, very important. Your visuals should have very, very good headings, and it must convey an independent information. Let's now look at some data analysis tools. Choosing the right instrument for your data and for your question. At this stage, you must understand something very important. Data analysis is not done in your head. It is done using tools. The credibility of your research is strongly influenced by, one, the tool you use, two, how well you use it, three, how well you interpret its output. The tool you use, how well you use it, how well you interpret its output. And why do we use data analysis tool? To be clear, manual analysis is very slow. Manual analysis is error-prone. Manual analysis is limited. Tools allow you to handle large data sets, perform complex calculations, generate accurate outputs, and produce professional visualizations. So we have quantitative analysis tools and qualitative analysis tools. For quantitative analysis tools, one of the tools usually used traditionally is the SPSS, Statistical Package for the Social Sciences, SPSS. This is one of the most widely used tools in social sciences, education, and business research. SPSS is used for descriptive statistics, correlation analysis, regression analysis, t-tests, ANOVA. So SPSS does the calculation, it gives an output, and you explain what it means. Does the calculation, gives an output, but you have to explain what it means. So any discipline with structured survey data can use SPSS. Even if you are doing life sciences and you have structured survey data, you can use SPSS. Another important quantitative analysis tool is GraphPad Prism. This is used heavily in biomedical research and experimental sciences, where most of you belong to. What does it do? It does statistical analysis, graph generation, and curve fitting. It produces publication quality graphs. Another one is Excel. And Excel can also be integrated with AI Copilot that will make it highly intelligent. Microsoft Excel is the most accessible tool. It is used for basic statistics. It's used for data cleaning. Remember, I say you do your data cleaning before you go into analytics. One of the things that can help you with data cleaning is Excel. Excel can help you with data cleaning and can help you create charts. Excel, however, has limitations. It is not ideal for advanced statistical testing, except if it is the one that is integrated with AI copilots. Another quantitative analysis tool is R, or R Studio. This is an advanced tool used for complex statistical modeling, advanced visualization, but this requires coding knowledge. You must know how to do R coding. And it's a beautiful thing that I'm seeing today now that they are teaching undergraduates, biomedical students, R coding. I don't know if they have started that in JOS, but in IBB University, they are doing a lot of R coding for life sciences students now. It's one of the things you must learn in 200 level, R coding. And I think it's very, very important. I think every university should adopt that. For the qualitative analysis tools, you have things like the NVivo, which is important to organize text, audio, video, and image data. Code segments, build nodes, hierarchies, map relationships between codes. We talked about coding earlier, and these tools can help you do your coding. Coding text, identifying themes, organizing qualitative data. So what do? You import your transcripts into NVivo, highlight the text, create nodes and codes, and group the nodes into teams. It's best for large volume qualitative data sets, team-based qualitative projects, thematic grounded theory, and narrative analysis. The atlas.ti is similar to NVivo. And it's used for coding, network mapping, thematic relationship, and can also do visual network maps, showing relationship between code teams and documents. Strong discourse and conversation analysis. Its distinct strength is that network diagrams, the network diagram make your analytical reasoning visible, showing how codes relate to each other in a way that enhances both your analysis and your presentation. Best for discourse analysis, comparative qualitative studies, researchers who think visually about conceptual relationships. Maskida. Combines qualitative coding with quantitative frequency analysis, strong for mixed methods design. Remember we talked about mixed methodology in the last class. So you can use this for your mixed method analysis, built-in sentiment analysis, and code frequency visualization. It bridges qualitative and quantitative, allows you to quantify qualitative terms without losing interpretative depth. It is best for mixed method research, content analysis, studies where quantifying qualitative pattern is analytically significant. The goal here is that each tool serves a purpose, and you must identify the purpose you want to use it for before applying a tool. Now let's look at AI-assisted data analysis. AI-assisted data analysis. We move to something very important here, which is AI-assisted data analysis. The evolution of data analysis is such that we are no longer in the purely manual era. We are now in the AI-augmented research environments. And for AI-assisted data analysis, the AI helps with pattern detection, automation, visualization, prediction insights. But one thing we must take note is that AI does not replace statistical reasoning. It accelerates and enhances it, but it does not replace statistical reasoning. You must have that at the back of your mind while doing your work. We have AI-powered data analysis platforms like Julius AI, which is a data analysis AI tool. Here you can upload your data sets, which can be in the form of CSV files or Excel files. It will automatically analyze the data, generate insights, and create visualizations. So when you upload your data set into Julius AI,
Hi, Prof. We can't hear you. Okay. Hi, everyone. Prof will be back soon. I guess it's network.
I lost data briefly. I'm sure you can hear me now.
Yes, we can hear you.
Okay. Okay. Yeah, we are back. So I was talking about Julius AI. Once you upload your data set and you ask it to analyze trends in the data set, it generates charts and insights. You export the result and you interpret it. You don't need any coding knowledge to be able to do this. And it does this for you with ease. Tableau is a traditional AI software, but it now has some AI. It's a traditional data analysis software, but it now has embedded AI features. And Tableau can be used for advanced visualization and to create interactive dashboard. So when you import your data sets, you drag your variables into workspace, choose chart type, use explain data of the AI feature. It gives you industry standard visualization. There's the Microsoft Power BI, which also now has embedded AI tool. And also the same thing, create data dashboard, real-time insights. We also have Polymer Search, NVivo, Atlas TI, .ti, and Mascada. All of them now have embedded AI tools. So there are certain things we must take note of here. AI can misinterpret data. AI finds statistical patterns. It cannot assess whether a pattern is theoretically meaningful, contextually appropriate, or is spurious correlation. It is for you as a researcher to know that. Allow you to identify patterns for you, but do your interpretation yourself. AI can detect false patterns sometimes, especially in a small or noisy data sets. So that is why you need to do your cleaning very well. AI optimizes for patterns, pattern findings, not for truth finding. Always validate AI detected patterns against your theoretical framework. AI can oversimplify results. Complex multidimensional findings become 3-bullet summaries. Never let an AI summary replace your full analytical engagement with your data. So, be the boss, just like we always say, always be the boss. Never report AI output without first understanding it. If you cannot explain it in your own words, what the AI found and why it matters, you are not ready to include it in your thesis yet. So when choosing an AI tool, ask what type of data do I have, what level of analysis do I need, and what tool fits my skill level. The tool does not make a researcher. Your understanding does. AI can accelerate your work. Software can structure your work, but only you can interpret, defend, and own your research. Only you can interpret, defend, and own your research. Let's look at writing your results section. Your results section has a structure of introducing, state what data was analyzed. This chapter presents the finding from a survey of, say, 120 early career academics. State how it was organized. Results are presented in 3 sections, addressing each research sub-question in turn. Brief statement of any analytical decisions, software used, any exclusion made, level of significance adopted. This should all appear in your result, the introduction part of your result. Before you go to presenting the results, you must have an introduction part before presenting the results. In presenting the results, you think in terms of quantitative or qualitative. If your work is quantitative, then you are looking at tables plus explanation. You present tables and figures, then explain them in prose. Every table and figure must be introduced, described, and linked to the research question in your text. You explain them in prose. Don't use bullet points. use prose to describe your tables, your figures, and link them to your research question. So like we keep saying, your research question is very, very important. We started out talking about research question, and we have not stopped talking about research question. So you must be able to link what you are doing with your research question. If it is qualitative, present themes, then evidence them with participant quotes. Each theme requires a name, an explanatory sentence, and at least one direct quote. Do not present raw data. Present analyzed findings, patterns, relationships, themes, and frequencies that are the product of your analytical process. If you think your raw data is very, very important, and sometimes it is very, very important you have them, they should be moved to your appendix, and you can reference the appendix from your table, from your results section. But never, ever present your raw data in your results section. Your results section should only have analyzed data that have been analyzed, not your raw data. Then in writing your results section, there's what we call the clarity rule. Present findings in the order your research questions demand, not in the order you found them. Remember how your research question was framed. So when you are presenting your findings, present them in the order that your research questions demand, not in the order in which you found them. Report all significant findings, including unexpected ones. Selective reporting is a form of bias. Sometimes we may be doing a research and we find something that is not in tandem with what we expect. One of the things that researchers tend to do is to hide such information so that they'll have a research that is clean and follows all the rules. But that in itself is a very bad research practice. And you never can tell. Maybe that new information you have seen is something that in the next 10 years will be the current knowledge. And by that time, somebody else will report it as something new, and they will be celebrating that person. Meanwhile, you have discovered it 10 years earlier, and you hid it because it was not yet mainstream. So anything you discover, you must report. Use precise language. A statistically significant positive correlation was found. Not there was a relationship. Your language must be precise. Keep interpretation minimal. You are not supposed to interpret in the results section. Save theoretical engagement for the discussion chapter. Do not do interpretation or draw inferences in the results section. That is the clarity rule. So do not interpret too deeply here. Just present the finding clearly. Just present the finding clearly. So, as your deliverable for this week, you should have a 2 to 4 page Word document, one paragraph of introduction, what data was analyzed, how the chapter is organized, any analytical decision. You are writing a results section here, right? For quantitative, at least one table of figure, formally introduced and explained in prose, statistical results reported with precision That is statistics, degrees of freedom, p-value, effect size, and so on. If it is qualitative, at least 2 teams, each with a team name, explanatory paragraph, and minimum 1 supporting participant quote. Research question alignment. Every section maps directly to a research sub-question. The reader should be able to see the correspondence. Note, there should be no premature interpretations here. Findings are presented, not yet explained, through theory. Save theoretical engagement for your discussion. So this is what I want you to do. Everybody here must have done a research before, or you have a research you are currently doing. If you have results already, do a results section using the pattern we have done today and submit. It should be about 2 to 4 page document. If you are not currently doing a research, the research you have done before, go back to it and try to reorganize it using this format. Then you submit as your deliverable for the week. So as we end today, data does not speak. You are the one that gives it a voice. And the strength of your research will depend on how clearly, honestly, and intelligently you allow data to speak. Thank you very much.
Thank you so much, Prof. Oh my gosh. Guys, can I get a thank you in the comments? Can I get a thank you, Prof, in the comments? Thank you so much, Prof. Thank you so much, sir. That was very needed. I'm going to open the floor for questions now. I'm going to open the floor for questions now. If you have questions, please raise up your hand. If you have questions, please raise up your hand. If you have questions, please raise up your hand. Anthony, do you have questions? Do you have a question? Okay, while people are still thinking of their questions, I have Prof, please, can you help us mute? Okay. So I have a question. So I think the other, okay, thank you very much, sir. Okay, so I have 2 questions. The first one is concerning the deliverables. What about people that are not able to meet up with the what's it called? The results section, sorry. The people that are not able to meet up with the results section. Let's say I'm going to use Juliana as an example. That is a 200 level undergraduate student and probably have not done any like research or written any paper or any manuscript before. Maybe how can she approach the assignment?
Hello? Uh, hello. Okay, great. Now, I think for someone like Juliana who might be able to excuse her, I think she's just here to immerse as much as she can from here. This program is not designed specifically for undergraduate students. So whatsoever she's learning here, let her just learn and she can use later. But we'll not be expecting deliverables from people like her.
Okay, thank you very much, sir. My second question, this is my own question.
Did you hear me?
Yes, sir. Can you hear me? Yes, sir. I heard you. Can you hear me?
Did you hear me?
Hello?
Oh, wow. Okay, can you hear me now?
No, we heard you and we heard everything you said, sir.
Okay, great.
Yes, sir. Thank you, sir. So my second question, I'm a bit curious. How do you, if you have like a set of results that you've analyzed, in fact, you've not even analyzed, you've done probably you did a research, and then you have some results. How do you know the right statistical analysis to do? How do you know at what point to do standard deviation, a regression analysis? Maybe mean median mode are maybe very understandable, but for analysis like maybe hypothesis testing, how do you know, looking at your result, how do you know when to use each of these analysis for your results? That's my question, sir. Prof, we can't hear you, sir, in case you're speaking.
Hello? Come, let me try to fix this.
Hi, everyone. Okay.
Okay, great. Your question is that how do you know what to use, right?
Yes, sir. How do you know what kind of statistical analysis applies for your own results?
Okay. First, you must know what you are looking for. That is the starting point. What is the output that you are interested in? What are you looking for? If you are just going to be comparing groups, then you know what to do. If you are going to be comparing groups, for instance, then you know that you are going to use something like your t-test, your ANOVA. If you want to find out correlations between variables, you are going to do correlation analysis. If you want to know whether one variable predicts another variable, you are going to be doing something like regression analysis. So knowing what you are looking for is very, very important. I don't know if you understand what I'm saying and if that answers your question. You first have to understand what you are looking for before you can know the tool you can use to do that thing.
Yes, sir, it actually does. It actually does. So another follow-up question now that I have it. I know you can get this information online, but just so that you don't miss it, really, how many statistical analysis are there? And so, like now you said, if you're doing this, you know you're supposed to do this. How do you know you're supposed to do that? If maybe some people don't even know what statistical analysis are even available in the first place to even do. Do you understand my question, sir?
No. If we have a situation, for instance, you want to look at a group of students and you want to know how they use AI tools. You now want to also look at how their performance has improved from the use of AI tools. Now, I'll put this to you. What do you think you're expecting from such results? After first you do a survey of, say, 1,000 students, and you ask them, do you use AI tools? How regularly do you use AI tools? Then you also ask, what is your CGPA pre the use of AI tool? What's your CGPA post the use of AI tool? If you gather all this information, now let's look at it critically. What do you think you are looking for? What patterns do you think this information you have gathered has revealed? This will help us to know what you are looking for. Did you get my question? I want us to arrive at the answer together. That's why I'm asking this question. And anybody can answer me, please. I'll need you to, did you understand my question? Can you all hear me?
Yes, sir, we can.
Okay, did you understand my question?
So I did. Let me try.
Okay.
Okay, so I think we're trying to find a correlation pattern to see how AI use influences CGP, whether it increases it or it decreases it.
Okay. So what then do you think, what kind of tool are you going to use now?
Okay, probably a correlation analysis tool.
Okay. Any other person? Any other person? Let's understand this together and answer it, please. Please, I want every one of us to talk.
Sorry, sir. I logged out for a bit. In fact, I missed maybe the question.
Okay.
The last thing I heard you. Okay.
The question I asked is this: if I survey a group of 1,000 students and I ask them some questions, do you use AI tools for studies? How often do you use them? What was your, if you use AI tools, what was your CGPA pre the use of AI tools? what is your current CGPA since you have started using AI tools? And you now gather all this information together. What do you think you are looking for at the end of the day after you get all this information? What are you looking for? That will now help us to know what kind of tool we are to use to do them.
I think based off of what you've described, you're trying to evaluate the performance of those students before they knew about AI, they started using AI, and after they started using AI. So you want to compare those two.
So what meaningful information can we generate, and from that data set?
Okay, well, you can find out in a number of people the total number of people that actually use AI. You can find out how AI has impacted the class of people that actually use it.
Okay.
Yes, I think
so now what tools do you think we can use there? Okay, let me put it this way. If you are doing statistical analysis, we can do comparison tests. For instance, we are comparing between groups. If you are comparing the means between two groups, for instance, the means between two groups, what you are going to use is something like t-test. These tests help you to compare means between groups. If you are comparing means across more than two groups, 3 or more groups, then you can no longer use t-test. Use ANOVA, which is analysis of variance. So you know what that type of data you have generated. If your data have generated is that it will make you want to compare means between two groups, then you go on to use t-test. If it is a means across various groups, you use ANOVA. If you are comparing frequencies, categorical frequencies, then you'll be using things like a chi-square test. But if it is relationship you are looking at, your relationship could either be correlation or regression. Is correlation when they measure between two variables? If you have two variables and you want to measure the strength, how one association leads to increases the other one, that's correlation. But if you want to know whether one variable will predict another one, use regression analysis. Then there's things like distribution and normality tests, and so many of them. So your research question determines what kind of test you are going to do. So if you go back to your research question informs almost everything. Your research question determines the kind of method you do. Your research question determines the kind of literature survey you do. Your research question also informs the kind of statistical analysis you are going to do. So your research question best answers that question of what type of statistical analysis you are going to use. So if you have two groups, you do t-test, 3 or more groups ANOVA, 1 predictor, simple regression, multiple predictors, multiple regression, and so on. When we finish and we look at this whole thing holistically with a complete paper from the beginning, we'll be able to trace how our research question leads to every other thing. Does it make it clearer now?
Oh, yes, it does. It actually does. Thank you very much, sir.
Thank you.
Okay, so does any other person have any question? Please, in the meantime, I'm sending an attendance form in the group chat. Sorry, not group chat. Here in the chat section. Please kindly fill it. Fill for yourself alone. I've sent it right now. Please fill the attendance form. Thank you. So does any other person have any question? Do we have questions? Okay, Mr. Simon, your hands are up. You can speak.
Okay, thank you very much. Hello, sorry, are you getting what I'm saying?
Yes,
we
we
can
can
hear
hear
you.
you.
Oh, okay. And thank you so much for this very good opportunity. And it's just bad that my